guys once again to another video. Today I'm going to be talking about metal science. It's a subject called metal science. So generally I'm going to introduce you to this subject. It's also a subject in engineering. So what is this subject so about? So generally in metal science, it's actually a department of science which studies the composition of metals, their properties, and actually also they study how the chemical properties of metals are connected to the structure, and the chemical properties also connected to the properties of metals themselves. So after that, in this department also we further study how external factors affect the properties of metals and the structure of metal. So generally, what are metals and how can we know that an object is in the metal? So the basic signs of metals are just like it's their electrical conductivity, their plasticity, and their heat conductivity. Finally, metals are shining generally. Okay, so metals are actually crystals. They are crystal objects. And what do we mean with crystals? A crystallic object is just an object in which atoms are arranged in a certain order. It's different from amorphous matter where atoms are just chaotic. Yeah, so this is what we mean with crystallic body. Okay, so generally in crystals we have a structure, and it's like the structures of metals. It's like we can basically imagine them to be lattices in which each node represents an atom. So generally the smallest lattice structure, which is the smallest volume of a metal, which just give us the way atoms are arranged, it's called a unit cell. So generally it's just the smallest structure, just the smallest volume, which just gives us the way atoms are arranged, the certain order in which way atoms are arranged. So that smallest volume, we call it a unit cell. So generally, let me show you what we mean when we talk about a unit cell. So now, looking at the screen, this is a unit cell. So generally a unit cell is the smallest volume of a metal that gives us the way atoms are arranged. So in a lattice structure, these are nodes, and these nodes, this represents atoms. So generally with metals, all metals, they have a certain type of lattice structures, and these lattice structures are a little bit different. And different metals have different certain structures, these lattice structures. So generally, let's see what kind of lattice structures that we have. So we have the first one, this one. It's called body-centered cubic, something like that. This structure is called, the first one is called body-centered cubic. So generally, what is the body-centered cubic, BCC? It's just a structure, and if we look closely, we have a cube, and at each corners we have atoms. But right in the center of the cube, we have also an atom. So this is the first structure, and these are examples of metals with this kind of lattice structure. Okay, so the second lattice structure that we have is face-centered cubic, FCC. So here, what is it? Each surface of this cube, each face of the cube has an atom at the center, that is the upper surface, or the sideways surface, and all in the lower surface, the bottom surface. In each center we have an atom. So the third one that we have is the hexagonal. So the hexagonal is just like this. As you can see, we have 6 sides. And remember, the thing that you should also remember, between these 2 layers of hexagons, we have a triangle, there are atoms between, and this is how the hexagonal lattice structure looks. Okay, but now these are lattice structures. These are ideal lattice structures. Okay, we should understand these are ideal lattice structure. But in real metals sometimes we don't have these structures. Why? Because we also have some defects. So what is a defect? So a defect is when we have these structures, any of them are violated, okay, in any way, so it results in defects. Okay, so generally we are going to look at the types of defects that we have, and there are 3 types of them. The first type of defect is called the point defect. We're going to look at what's called point defect, and we're going to have also linear defect. We're also going to see what is it that we call linear defect. Also, we are going to have what we call surface defect, and we're also going to see what is a surface defect. Okay, guys. So now let's start starting by point defect. So these are the types of point defect. So the first one is called vacancy. That's when we have this one. That's when we have a missing atom. So the A represents the ideal, B represents the vacancy. That's when we have an atom missing in its position, and right round we see the stressed atoms. And we have C. C is called substitution, and with C now we can see that it's another atom, it's an impurity atom, and it's a different atom from the rest, and it's cause stress is around because it's too large. And we have what we call interstitial, that's D. So it's an atom that it didn't substitute, but it just went in between other atoms. So that's what we call interstitial. So actually this is all what we need to know about point defect. These are types of point defects that we have. For now, it's only enough to know only these ones. Okay, so going further, we have what we call linear defect. As we have mentioned that there are 3 of them, types of defects. So until linear defect, so generally what we mean with linear defect is best to describe it as dislocation. So with dislocation, we have 2 types of dislocations. We have edge dislocation and we have screw dislocation. So generally, what do we mean when we talk of edge dislocation? So generally, I'm going to show you on the screen. So here is what we call edge dislocation. So this is edge dislocation as you're seeing it on the screen. And as you see, this layer is just moved, and it's just moved. This one moves to this, and this one moves to this. So this is what we call edge dislocation. And we have what we call screw dislocation. So screw dislocation happens when we have a rotational movement. So, and the layers, they like rotate. That's why what happens is when a layer doesn't completely dislocates from another one. Okay, So it's just like a little bit, and the rest part remains intact. But with edge dislocation, all the layer dislocates of that metal. So these are two types of dislocation. So we also have what is known as dislocation density. Okay, so what is dislocation density? So dislocation density, by definition, is total dislocation length per unit volume. Okay, so what is total dislocation length? So it means we're going to measure the total length of the lines of dislocation and divide it by the volume where these lines have been counted. Okay, the length where it's been measured. Okay, so that's what we call dislocation density. So it is also important to know how the dislocation density influence strength of metal. So the relationship between dislocation density and metal. So for this, we have this graph. I'm going to show it on the screen. So this graph is just the effect of dislocation density on strength. So generally here, this is the ideal strength of a metal. So this one, ideal strength, it's also called the theoretical strength. This is the strength that we can calculate, but the strength of real metal is just the lowest. So this is the lowest value. It happens when we have pure metal. So with pure metals, we are going to have the minimum strength. They're going to be weaker. But as we are going to have alloys, the strength is going to increase. So the strength increase. Generally, the graph starts to increase as we're going to have alloys again. But not that the minimum value happens with the pure metal when we are going to have a clean metal, 100% clean. So the metal is at the weakest point. All metals are weakest at weakest point when they are pure. That's what this graph is showing us, guys. So finally, we are going to talk about surface defect. What is surface defect? Now, surface defect, it's actually this one happens on the surface, and usually atoms of any metal, of any body atom. So at the surface, they position them in such a way that with the minimum energy. I'm going to explain this. For example, liquid drops, and it means all the atoms will drop and position them at in a position where there's the least amount of energy. Okay, so this also happens with metal at the surface of metals, and it's actually these stresses from the external factors are called surface defects. So that's all for today, guys. This is just our introduction to metal science, and next time we'll continue from where we left. So guys, this is it. Subscribe and enjoy engineering subjects, guys, and this is good for you who are interested in engineering. These things, if you are going to become an engineer, you will be repeating them, you will be facing them, you will be required to know them. Okay, so that's it, guys. Stay tuned.